I know you're inside, you're feeling so hollow.
Oh my god! Hey guys, is that Gavin and John from my high school
Sarah
physics class?
Byrne!
Well, I haven't seen you guys since like my junior
been
year
so
high school
long.
physics, man. Hi, how are you? Hey John.
Go!
Hi, Sarah.
How are you guys?
Hey, we're just sitting on
Do
this
you
bench
remember
right here.
that junior year high school physics class, physics honors?
Oh yeah, with Miss
Oh my
Trioni,
God,
right?
Yeah,
Yes.
well, Miss Trioni. I'll never
God.
forget that. Notes.
Oh
Oh, that
yeah.
was so funny.
And then her phrase, handy dandy calculator.
Oh yeah, every
Oh,
time
yeah.
we had to do calculations.
And remember, every
handy
time we had to start a
calculator.
project or like a thing in class, she'd say axolotl. As
Oh
our-
yeah,
hilarious.
that was so funny. Oh my god. Oh my god. Remember when we had that sub, Mr. Signs?
Oh yeah. What? What? Remember that?
Like, every time?
Every time we would ask a question, man. What do you guys think the funniest part of physics honors was?
Remember the time when Tateva got shocked by Gavin's project?
Oh yeah, yeah. I made that project, the Leyden jar, right? The huge Leyden jar I made.
Oh yeah, I remember that project. It was huge. I was scared that she was gonna call on me to get shocked by that. I feel so bad for Tatevik. Remember how loud she screamed?
Yes, that was so loud. The whole class must have heard it.
Yeah.
Okay, remember that she got shocked, and then there was even like a blue spark from her finger to the machine.
Oh yeah.
Yes.
I feel so bad that she got called on for that one. You guys want to go get lunch or something?
Sure.
Sure.
All right, cool. Let's... What do you guys think the most amazing thing that we learned that year was?
I'd say Newton's first law.
Oh yeah, I
Wait,
remember that one.
what was Newton's first law again?
Oh
Come
yes.
on, John. Come
An
on, John.
object in motion or rest will stay in motion or rest unless acted upon by
An
an
unbalanced
unbalanced force,
force.
right?
Yeah. Okay.
Yeah.
The most important thing I learned in that class.
Yeah,
I have
that
to say.
was probably the most amazing
Physics is
thing that we
based on
learned.
that.
It's really cool. You know, I think that physics really helped me like throughout college and throughout high school. You know,
I'd say
like,
so too.
yeah, it kind of like gave me a different point of view of the world. Like before, I would always take these like religion classes or English classes or whatever, where a lot of things were like related to the Bible. But now I've realized that you know, physics kind of explains like the world. It's not really, you know, religion and stuff. It's really about physics, which is really interesting.
That's an interesting topic. Yeah.
Yeah, it also really helps me with math. I mean, like all those equations that we practiced.
Yeah, I can see that. Physics has really helped me think of concepts in a different way, such as like a car moving at a constant speed, and then how to conserve on gas.
Yeah, it
Yeah.
really just gives you a different point of view of the world. It's really helpful, especially all those equations in math, man. That really helped. Hey, here. What's up, man? I haven't seen you since like physics, high school. Wow, junior year. Yeah, I was just talking to Gavin and John. We're all gonna go get some lunch. Would you want to come?
Yeah, that was great.
Awesome. How've you been? No, well, if you like could go back to high school, what would you tell, like, you know, future physics students? Like, what advice would you give them? Okay, I would like tell them don't be afraid to get help. Like Miss Trioni has office hours like Tuesday and Thursday at lunch, and it's really helpful if you like go in there and get help, especially if you're confused, because the more behind you get, you just keep getting more and more behind, you know?
Help. When I went back, I would tell the students to focus more on like studying for tests. Do you agree?
Yeah, do the test
That's what-
topic sheet, right?
Tests were definitely hard in that class.
Yeah. Hey, what do you think of when you think of our physics class?
When I think of physics, I think of waking up 7 a.m. in the morning
Oh
and
my
getting to physics.
I hated like physics first block, but it was really funny because all those people were always late. Like remember Near was always late, like every single day. Gorov.
And Lena.
Oh, Lena every
and
day.
Brian.
Yuri would walk in like super late all the time. Oh, and Ashita, remember that phase where she would always be late? That was so funny. Oh my god, Miss Trioni hated when people were late.
Yeah, and then she would be like, "It's spring. I don't want to deal with you right now."
Yeah.
Remember when we did engineering projects throughout the year?
Oh my gosh, yes. All those all-nighters and testing it like over and over and over again.
Yeah.
I'll probably definitely think of that when I think of physics.
Yeah. Hey Gavin, how do you think physics has changed your life so far?
I don't know. Well, look at me right now. I'm doing circular motion. You know, I'm balancing gravity, but you know, in all reality, you know, my driving will be totally different now. Like, you know, usually when you drive, you go stop, hit the red lights. But now, instead of just driving and wasting energy like that, I'll just cruise slowly into the light. That way, I don't like completely stop and waste energy. I'll just keep going straight through them.
That's cool. for lunch today?
Well, I just made us some pasta. I just need to heat up the sauce in the microwave. Hey! Microwaves relate to physics! I just put the sauce in, close the microwave door, and I press number, and the microwave goes.
And then Gavin, you all be like.
Microwaves are a form of electromagnetic waves, which are a transverse wave consisting of oscillating electric and magnetic fields at right angles towards each other. I remember that Ms. Trioni taught us there were a couple different kinds of electromagnetic waves. Do you remember what they were?
Yeah, there's the microwave and then there's the TV. See, watch. You just turn it on. Electromagnetic waves will come to life.
Waves.
Wait, radio.
So, we're eating lunch, guys.
It's good, thank you.
Pasta, yeah. I
Thanks,
made that
Sarah.
in that microwave with the
Electromagnetic
electromagnetic waves, yeah. And the whole TV. That's so cool. What else do you guys remember about physics? It was a long time ago.
I remember having a good time.
A good time.
Does anyone remember conservation of energy?
Oh yes, that's my favorite part of physics.
Oh yeah, the energy before equals the energy after. The sum of the energy before equals the sum of the energy after.
Yeah, and then the conservation of energy states that energy is neither created nor destroyed, and is only transferred from one object to another.
So where?
Kinematics. Yeah, I remember. Isn't kinematics like how things move?
Yeah.
Yeah. He wasn't so good at explaining.
Put on a video.
Come somebody.
It's always a good time.
I need your darling, come and set the tone. If you feel before, won't you let me know? Oh,
It's physics. When you slide down this slide, you actually have conservation of energy. Conservation of energy is the sum of the kinetic energy before equals the sum of the kinetic energy after.
The kinetic energy formula is 1/2 mv squared.
So initially what you have is you have the MGH, so all you have is height. And then after that, as you slide down, it turns into kinetic energy. So instead of just being gravitational, it turns into kinetic energy, but then you also have like frictional energy, which causes you to take even more energy away. So once you get all the way down, then you finally just come back to MGH again. So you end up just only having MGH again.
So the sum of the energy before his mass and his velocity is 0 is equal to the sum of his energy after, because his final velocity is 0 again. So his mass is equal to his mass.
Conservation of energy!
So Newton has 3 laws. Okay, the first law is the law of inertia, which states that an object will remain at rest or moving at a constant velocity unless an unbalanced force acts upon it. And inertia is the property that keeps that object at rest or keeps it moving at a constant velocity. So Newton's second law is F net equals ma, which is force is equal to mass times acceleration. So that means that if you give 2 objects the same amount of force, the object with less mass is going to actually accelerate a lot faster than the object with more mass.
Example of Newton's second law is when a truck and a car hit each other. The moment they hit each other, their force equals the same. Therefore, the car that weighs less would have a greater acceleration, and the truck would move less because it weighs more.
Newton's third law states that every action in the universe has an equal and opposite reaction. An example of this is if I were to punch Neo in the face. For example, if I punched him in the face like this, my fist would create a force. But his face would also exert the same, an equal and opposite force on my fist as my fist exerts on his face.
Oh my god! Ah! The electricity went out! What are we gonna do?
I have no idea.
Does anyone have a flashlight? Let me look for one.
Thank you, awesome.
Oh my god! This is awesome. We can tell scary ghost stories now.
When you turn on a light switch, the light comes on almost immediately. For this reason, many people think that electrons flow very rapidly from the socket in the light bulb. However, this is not the case. When you turn on the switch, an electric field is established in the wire. This field, which sets the electric charges in motion, travels through the wire at nearly the speed of light. The charges themselves, however, travel much more slowly.
These electrons do not move in a straight line along the conductor in the opposite direction of the electric field. Instead, they undergo repeated collisions with the vibrating metal atoms of the conductor. This is called drift velocity.